Let me just start with a couple questions. Raise your hand if your primary responsibility is software development. Okay, awesome. And how about if your primary responsibility is architecture, systems or application? Excellent. This makes me so happy because I speak at a lot of conferences which are just managers and just sort of business interests, and this is near and dear to my heart. So I'm starting you here with a quote that I love with respect to business, which is essentially it's a question about what are you optimizing for. This is an investment philosophy for this management guru, Peter Lynch. It's also something that Warren Buffett, Charlie Munger like. But it generally speaks to this concept of, you know, why don't we pick things that are going to be easier for us to make money on and run in the future as opposed to relying upon extraordinary talent. And I have my own version of this. It's nicer. I mean, this is kind of mean. I don't like the word idiot, but you know, we're talking about non-technical people, so I think it's okay. We have pointy-haired bosses here. But this is my version of it. We should be writing software that the average developer can support. And I fundamentally believe that this is how you develop maintainable software. We develop software forever. The days of we develop something and we're done and we move on have ended, certainly with software as a service. And so we have to develop forever. We might as well make it maintainable. And to me, I have a strong corollary to this, which is that more maintainable software generally means less code. So all things being equal, two applications, one has less code, one has more code. The one with less code is easier to maintain. And when I say code, I really mean custom code. So one example of this is if I have developed an amazing bespoke CMS, but I had to develop all of it, I did all the code, right? It was very tight, it's very beautiful, versus I'm using WP Engine or WordPress.com, which is a nightmare if you've ever looked at the WordPress code. It's a nightmare PHP scenario. But guess what? If I can outsource that to WP Engine or to WordPress.com, it's not my code. So that's less code if I can use that, even though it is a dumpster fire. OK. So I want to start. So OK. My name is Joe Emison. I'm going to talk about serverless patterns and anti-patterns. Fundamentally, this is a talk about architecture. And it's a talk about, really philosophically, that software development should be about the value it delivers and not what is within software. I'm going to talk a lot about architecture in this talk. I don't have any code samples, but I'm happy to give you lots of code samples as follow-ups to this talk. But deeply, we're getting into architecture. And even if you are not the architect, right? You are the lead developer or a developer on a project. In my experience, you have enormous influence in terms of architecture. You have enormous influence when you're given an assignment to say, OK, I could write this, but actually, why don't we just leverage this other thing that already exists, for example, right? Or why don't we do this other way? If you work for an organization where you get shut down on that, I would strongly suggest go work for another organization, because there are lots of us that encourage the people that we're giving work to be empowered and suggest better ways of doing it. All right, so let's talk about what the agenda of this talk is. I'm going to go into 3 parts, OK? So the first part is about what, why, and how for serverless. So serverless is a charged term. I am frequently told, there are still servers. So what do we mean by serverless? And I have my own definition of this that I think is very useful to understand all of the value that I'm talking about. I'm going to tell you what the main benefits are, so be more specific about the value. And then I'm going to tell you about the biggest hurdle to adopting serverless in organizations in my experience. Then I'm going to talk about my relevant experience. I'm going to go through 4 applications. I'm going to go through relatively detailed architectural diagrams. I'm going to talk to you about good things and bad things about those architectures and lessons learned within those. So I have 4 different serverless apps. All are different from each other. All good, scalable. There was no failure to launch. All, generally speaking, all good things with them. And then finally, the patterns and anti-patterns that hopefully you're here for, some key knowledge and takeaways that you have. And when I run my teams, they're the exact specific things that I say. When somebody says, well, should we do X or Y, this is the list that we go to. I find it incredibly useful. It's pretty comprehensive. All right, so let's start with definition. What does serverless mean? So my definition of serverless is no server operations, okay? This is, for me, a very clear line. And what I mean by no server operations is probably best understood if we look at what has happened over time with the gradual sort of abstracting away of our infrastructures. So we lost the power, the internet, the network, the sourcing, the CapEx, the OS patching, right, as we're going to containers, right? Serverless is this additional step which says, I don't even have application level operations. So for example, I would consider a server operation, oh no, I have to patch Nginx because of Heartbleed, or oh no, my application just went down because of some segmentation fault in my web server, right? Or in my application code on that server. There's a corollary or sort of a follow-on from no server ops, which is it's not my uptime. This is very explicit, and again, this has been a gradual step from data center all the way to containers and then to serverless. Not my uptime means, you know, when I took power and internet away from my control and into the data center, the colo facility, that was their uptime problem. But I still had lots of uptime problems to worry about, hardware failure, et cetera. And as I move along that path, even if I'm in a container world, right, again, if I have application errors, or I have some n number of containers running something, and if I have problems that happen in those, that's my uptime problem, okay? A serverless application is one where I have no control over my uptime. It is my cloud providers who are running my uptime. This is, in my mind, why serverless is such a big deal. It's because we've been slowly chipping away at this uptime issue and being able to outsource uptime the way we outsource the uptime of our power to power companies. And serverless is this last necessary step. And while it has been iterative, it's sort of been from where we had a vaccine that cured, you know, that still left 5% of the population vulnerable to the illness. Suddenly now 0% is vulnerable to the illness. And all of the uptime has been outsourced, okay? We've sort of crossed a chasm. So why? Why is serverless important? What are the benefits of not owning my uptime? And by the way, I bet a lot of you are envisioning all of the bad parts of not owning my uptime, right? Like, oh my goodness, it goes down and I can't do anything. And we know how hard it is to get some of our cloud vendors, like, I mean, we definitely can get them on the phone, but are we gonna send them an email, wait 24 hours? So we'll get to that. I'm sure you'll have questions about that. But let's talk about the good parts, about why this is great. And I have basically 4 categories of why serverless architectures are substantially better for greenfield development, let me caveat with, because any existing application we can sort of talk, there are different paths. But 4 reasons for serverless architectures being substantially better for greenfield development. So number 1 is the reduction of dependencies. Okay, and by the way, you can design serverless applications that have really awful dependency chains. So it's not like you adopt this and suddenly you solve it, but if you do it right, you dramatically limit dependencies. And in my experience, I've managed tiny development teams, I've managed very large development teams, and across all of them, what I will say is the major problem with getting good velocity, the major problem with unexpected delays, the major source of frustration on everyone's behalf is team interdependencies. And the worse the interdependencies are, the worse all of this is to some exponential level. And when I mean interdependencies, I mean the cloud revolution was largely that the developers went to the business side and said, hey, our operations people are so slow. Takes them 6 months to get a machine online. Just give me your credit card, $50. I'll just spin it up on Amazon. We can bypass those guys, right? That is fundamentally a dependency problem that was just bad and ingrained, right? But there are other dependency problems as well. Back end to front end, right? DevOps to back end to front end. All of these painful blockers. You've always got developers saying, well, I can't do anything because I'm waiting on so-and-so to implement what they need to. So serverless architectures done right just explode a lot of those dependencies, and you just don't have them. You've got very independent developers doing what they need to effectively. We'll get into more on that. Second reason for serverless architectures, code is a liability. Okay, I don't know if you're familiar with this concept. It's a great concept. It's very true. One of the problems that we have, especially as we are managed largely, or generally speaking, CEOs are non-technical. They view spending money on code. Well, you're spending money. We're capitalizing that development. And so it's an asset. It's on our books. Code is an asset. And so that's why you get these really terrible development metrics sometimes of like, you know, well, we're going to pay you per lines of code you write, or we're going to view your quality by lines of code you write. It's all terrible because in the end, you have to maintain this thing. You have to keep it going. The more code you have, the worse you are. So again, serverless architectures let you dramatically reduce the amount of code, bespoke code that you have. And it reduces and minimizes that liability. Third major benefit. Serverless gives you an opinionated, if done right, an opinionated microservices architecture for anything that you do. And Martin Fowler, who I love, has a great piece on microservices architectures, and he makes this point. He says, don't start with a microservices architecture because you're going to draw the services in the wrong places. And so what you're going to end up with is just a really bad microservices architecture, which is much worse than having a bad monolithic architecture, which then you can break apart in more sensible ways. And I think he's right when he says that, but here's the wonderful thing. If you really drive toward the right serverless architecture, then what you will actually do is get the right microservices breakdown from the beginning. I'm going to give you an example, and it sort of foreshadows some of the architectures I'm going to talk about. But let's say that you needed to do a lot of image manipulation in your application, which is very common. You need watermarks, resizing, blurring, content delivery, where you optimize for speed, thumbnails. If you used a service like Cloudinary, which has a published API, well documented, to do all of that, you just sort of handed that off to Cloudinary. You don't control that uptime, right? You don't manage any of that. You're just paying per use. If you did that, and then let's say you came around later and you said, wow, I don't like being locked into Cloudinary. Like, it's too expensive. It doesn't have some of the features I like. The latency is bad. If you did that, you would have a fully defined API and microservice for all of the image processing you needed would be there. And it fully tested, fully set up. And so you could say, OK, well, great. I'm going to migrate off Cloudinary to another one that I'm going to make API compatible. I'm going to write myself. And so immediately you get that benefit. Every time you use one of these services, you largely get your own development team, but literally you only pay them per consumption of the resource for your customers. It's delightful. So this is a huge benefit, I don't think discussed enough with serverless architectures. Finally, one of my favorite benefits of serverless architectures is that everybody gets a production environment because every cost is per consumption in these models. Okay? So what this means is every developer has her own full environment of everything. It means when you're running continuous integration deployment and you're testing, you just stand up a whole environment and you run all of your end-to-end tests in that environment. And the number of times where you have works on my machine, or you're trying to mirror environments, which is just a nightmare across large projects, it really starts to minimize because everyone has the same environment. There's another huge benefit here. Your DevOps is rock solid because if you can deploy an environment for every developer, and it's obviously the same everywhere, right? So it creates this amazing sort of scale and replicability across things. All right, now, last part in what, why, and how is the how. So what's hard about adopting serverless? So in general, I believe that the only things that are hard have to do with people. I think in general, when it's just sort of mechanical or automated, those things are pretty easy, or they're outsourced. But when it comes to your people, your teams, those are the hard things. And to me, what I've experienced, and I have had successful conversions of teams to serverless architectures, and I have had abject failures. And we'll talk a little bit about one of those in one of my architectures here. But when I think about developer identities, right, there is a problem in developer identities today, I believe, which is that there is a model of aspiration around solving scaling problems, building distributed systems. Back-end development is much more important than, I don't know, there's sort of a masculine aspect to this too, which seems somewhat toxic to me, which is like back-end is better than front-end, right? And so you get questions like this Quora question, which I saw and it made me feel, like, well, this is the problem that I try to eradicate, which is, why would you want to do web development? Because it doesn't have the fun stuff anymore because all the cloud developers do it, right? I mean, the reality is, from my perspective, everyone in an organization, from including developers, should not have identities built around the stuff I do is cool or hard. It should be based around, I am building value for my customers and my organization, right? And largely, this means I care about customer interaction. I want to delight customers. I love seeing delighted customers, as opposed to like very much heavy lifting in the back end. OK, so there's the summary. This is where I'm coming from in terms of serverless. Let's talk about actual architectures that I've gone through. And if you want to make notes at the end about any specific questions about these, or hit me on Twitter to ask questions about them, I'm happy to answer any question that I can about them. So I'm going to start with sort of 4 applications. Here's the first one. Fuel SQC. Now, this is pretty obscure use case. There are oil refineries and oil pipelines who have all this equipment that they use to check whether the oil and gas has certain compounds in them, or whether they're too high, too low, what octane gas is this. And so they do all this monitoring, but they use all these machines to get these values, and they need to know whether the machines are working correctly. So they buy, like, this is 87 octane gasoline. They buy a sample of that, and they test it on the machine, and they note the deviance on the machine. The machine says it's 87.5, I don't know. And so anyway, they need a way to look at all this information, and EPA has just ramped up all its requirements on them, and they need to provide like a full spreadsheet of all of their work to justify this, and to justify that their machines are properly quality controlled, okay? So how do we develop this application? Largely what the application is there's information that comes out of laboratory systems. It goes up to this application. This application does a bunch of math on it. By the way, the math has to change regularly, okay? So all this math happens on it. You see charts, you see graphs, you download the Excel file, you hand it off to your EPA inspector, you're done. Okay. Another challenge here. By the way, the reason why I'm telling you a very customer-focused story here is because this is what matters to me, right? Like, are we actually providing value to people? The challenge in the organization here is that for a while, the only full-time employee in this organization did not know how to program, only knew how to build models in Excel, which made sense because that's what the output's supposed to be, is Excel, okay? So there was a development challenge, which was, how do we have a relatively small amount of development and then actually put a lot of the development into the person who only knows how to write spreadsheets. And so here's what we did. So we have an Angular application, okay? It just runs in the browser, right? And so we're using Firebase. So Firebase, if you don't know, you should definitely check it out. It's a product of Google Cloud. It was an acquisition. And Firebase for Fuel SQC handles almost all aspects of it. So it handles all the authentication. So user login, user logout. Handles all the asset hosting for Angular, so it's very fast, so all of the HTML, CSS images. It is a full database as a service. And here's the really important thing to understand. Most developers that I talk to who have never implemented like a full serverless application, never worked with like a Firebase or a Parse, they tend to have this feeling, which is very normal, which is, okay, I'm going to put code on a client, on a browser, and that's untrusted code. I mean, even though it's going to be obfuscated, like theoretically, anyone can reverse engineer it and see what it's doing, and it's making API calls, okay? So how can I enforce security if I don't have code that runs on a server in the back end that makes sure, like, hey, this person has a right to write this thing or read this thing, right? To me, the biggest challenge with all of this always was how do you get security correct? Otherwise, you're like Snapchat that had actually this open API that a bunch of people reverse engineered where they could just go request anybody's images just by hitting this insecure endpoint. How do you avoid that? Because that's terrible. The good news is Firebase is an example of a service that has really easy to use security rules. It's just executing really simple JavaScript. So you can literally, Firebase will authenticate a user, and then you can literally have in your Firebase configuration say, hey, this user only gets to write access to the path that starts with their user ID, for example. And you do much more complicated versions of this. So they have great examples there. And so that's what we implemented. So that's the database. Now, we had another question, which was how are we going to deal with this? The main person can't program, and we need to deliver spreadsheets. So we use Google Apps Scripts and Google Sheets. And so he builds Google Sheets. We have just a gateway that passes the data from, so you upload the data to Angular, it sends it to Firebase, saves it. Whenever you want to run a chart, the Angular pulls the data from Firebase. It then sends it to Google Apps Scripts, which sends it to a Google Sheet. Google Sheet does its work, sends output back, goes back to Angular, plots a bunch of charts. Done. That's it. This thing was about 120 hours of software development and thousands of hours of spreadsheet development. But it's great. It's got lots of happy users. It's sort of the premier tool in this space for oil refineries and pipelines. By far the fastest growing software in that segment. And it's been, from a business perspective, it's a wild success. You can look at this and say, this is insane. Like, I can't propose this. Like, I work for like a Fortune 50 company. Like, no one's going to do this. And that may be true. I just want to, this one is really to provoke you into thinking, like, you know, wow, like, you can actually do this. By the way, this has had essentially 100% uptime for 3 years. I mean, just no maintenance, no cost, no server hops. Oh, I forgot to say, we use some Google Cloud functions in there too, Firebase functions that trigger. So one of the things that'll happen is when we run, when an analysis gets run, sometimes you want to send an email off to someone. That just happens. It's essentially like a database trigger, which might give you, the shakes because like triggers and stored procedures sound terrible. And I think there are some pretty bad anti-patterns you can get into here. But it's fairly, at least they don't load the database. They're nicely offloaded into a queue to handle. All right, second application, Spacefill. So totally shift segments here. This is commercial real estate. Okay? And there's a real problem in commercial real estate if you are a tenant. Has anybody here ever looked for space, commercial office space? Show of hands, anybody? Okay, a couple people. It's really, from my perspective at least, it's really bad because your broker doesn't want to spend that much time with you. You don't know a lot about it. You go on a tour, you take some photos, you forget which photos were with which space. By the way, you forgot to take photos of the most important things. Half the stakeholders weren't on the tour with you. So this is an app that lets brokers make tour books, and they can make them collaboratively Google Docs style. That was a requirement because sometimes they're trying to rush to make them, to finish them right before the tour. And then they can share them as a PDF, or they can send a link to a mobile tour book to their client. And the client can go in the mobile tour book, in a mobile web interface, take photos and upload photos while on a tour. And by the way, infinitely many clients can go take photos while they're on the tour, and they all get put in the same location where everyone can look when they review after the tour. It was a very useful tool. We were able to get this up and running in 3 months for the first version. And it had great adoption, had over 1,000 paying customers when it was acquired. And unfortunately, the acquiring party declared Chapter 7 bankruptcy shortly thereafter. It may be coming back to life. The website is bspacefill.com. I think it looks like it may be coming back to life a little bit here. And let's walk through the architecture. So same user browser. This had an Angular component and a React component. It was on its way to being fully migrated to React. And instead of, compared to the last diagram, it used auth0 for user authentication. It largely did this for LinkedIn. We wanted to allow people to log in with LinkedIn. That's not supported by Firebase authentication, so didn't want to integrate it ourselves. Auth0 plays really nicely with Firebase. So you can authenticate to auth0, and then Firebase can be given, can be told, OK, this is the user ID who has permissions. And then again, you can control security that way. There's a big image component here. If you envision what's happening, people are like out in the field, right? And they're taking pictures of the spaces they're looking at. That's untrusted code running in a browser. They could be taking pictures of like illegal things that we need to censor, right? So what's cool about Cloudinary as a service is that we could hook it directly to the insecure code. The images would go up to Cloudinary into a moderation queue. And Cloudinary partners with a service called Web Purify. And within 10 minutes, 20 minutes, someone would have looked at the image to see if it had objectionable content. And if not, they would approve it. And then it would show up for everyone. And there are no servers. Cloudinary is just handling all this from untrusted uploads. And they'll handle rate limiting, and they'll handle DDoS and things like that. In addition, we had a need from the PDF generation. So we had to make PDFs that people could download. And we use a service called DocRaptor, which is, if you're familiar with Prince, which is like an HTML to PDF program, DocRaptor is like Prince as a service. It's a really great PDF generation service. But it has a secret key. This is a really common problem in serverless architectures. I need to use a third-party service, but either I can't expose the key to the untrusted code on the browser, or there's one of these cross-origin problems where I actually can't make a request from the browser to the service because it's not allowed by that service. And so you end up having to proxy some of these requests. So we use a service here that's made by auth0. I think it might be called something different now, but it's at webtask.io. But essentially, 10 lines of JavaScript that just say, hey, we'll take in this request coming from Angular. We'll verify that it's OK and approved. We'll go connect to DocRaptor with our private key. And then we'll go send the content back. And then finally, we use Segment, which is used to collect all sorts of user events and dispatch them to things like Mixpanel, Analytics, and a service called Customer.io that will send out emails. So we would do things like, we would send off to Segment through Angular all these messages like, OK, here's who logged in. Here's what they're doing. And then we could, in Customer.io, we could say, hey, everyone who logged in but didn't make a tour book in 24 hours, send them this email. Hey, do you need help making a tour book? Contact us. All of that, no servers, no backend, all just handled by these services. The lesson learned that I have from this project is that, in fact, I, as a very, very, very part-time DevOps and backend person, that's all I needed. I had a team. I had anywhere from 4 to 8, so 1 to 2 teams of front-end developers running this project for 18 months. And I probably spent on average less than an hour a week on all back-end development, and there really wasn't any, and DevOps work. This was very, up front, the first 2 weeks there's some effort, right? But then it just ran. Had great uptime, like 5 nines uptime on this. Worked very well. OK, third application, commercial search. So we're in the same space here of commercial real estate, but this one is like Zillow for commercial real estate. Also, sadly, in that same bankruptcy. But for a while, great site, hit over 500,000 monthly uniques, which is a lot for commercial real estate. It had features like, hey, we need to search by full text, we need to search by facet, we need to search geographically, move the map around, refresh our search items. So speed was super important. It also got most of its traffic from SEO. So there was a big component of how do we make this SEO friendly? How do we have pre-generated URLs? How do we have a blog that's supportive of that SEO strategy? And so here's what this architecture was. We had a user browser. We used Netlify in this case. So in the past 2 ones, the asset hosting for the application was Firebase hosting. In this one, we use Netlify. We use Netlify for 2 reasons over Firebase hosting. One of them was pre-rendering. So if you want to do any pre-rendering, there's a service called prerender.io, but Netlify has that built in as well. you got to pre-render stuff. Otherwise, Google and Bing won't see any of your pages. Okay? The other reason we use Netlify was for reverse proxying. So a standard SEO problem is that if you have your blog at blog.domain.com, that is less good than having it at domain.com/blog. Okay? But you don't want your marketing people like in modifying things that could break your site. So the most effective way to do this is to reverse proxy on the domain and to send some request to another service. And so Netlify actually makes it incredibly easy to route all the requests to something like WP Engine running a WordPress site. And then the marketing team, by the way, dependencies, you're just eliminating a big dependency here. The marketing team can go modify the blog whenever they want. Doesn't impact anything else, even in configuration. Commercial search also used Firebase and for authentication as well. So for login, we needed to do search. So search is important. If you think about implementing a search like this, you might think, Elasticsearch. The challenge with Elasticsearch, and I love Elasticsearch, but the challenge is you have to proxy it. I mean, especially if you're running serverlessly, it's not like, it really isn't a great way to send requests directly to it. But Elasticsearch is not meant for like anonymous, untrusted users to hit. The good part about this service called Algolia is that it basically handles all of those scenarios that you're worried about for abuse for direct hitting. And let me give you one very specific example of what Algolia was able to do. So if you look up here at the upper right-hand corner, I guess for you, you can see a bunch of pins on a map, and you can see like a preview pane of listings on the right. Okay? And one of the things we worried about was how do you spider? Could you go just spider Algolia and get all this content? And what's great about Algolia is you can make a key. So you say, hey, here's my access key. And for the pins, here's what we'll say. We'll let you do a search. We'll let you get up to 500 results back. But the only fields you can get back on those are latitude and longitude. Can't get anything else. But we want to be able to do the preview pane on the right. And so that's another search key. And for those, we're going to let you get 10 back at a time, but you're going to get an image and some data. And by the way, Algolia is going to let me just rate limit all of those to say per IP, per hour, there's only this many calls you can make, for example, on these. And by the way, the API is really great, or the library is really great that lets you chain them together so you can sort of make them, well, JavaScript's great for parallel requests anyway. So that was great for Algolia. We used Cloudinary sort of same way that was used in Spacefill. And then we use Segment in the same way. And there was really important within this application for Segment to be able to capture analytics. Because if you're a broker and you put your listing on a site like this, you want to know who's hitting it. How many people looked at my listing? How did they interact with it? And you could think of that. That's like a classic need a backend use case, because you're like, well, I got to log all this information, I got to make it available to people, and there's like a lot of like security and trust issues. But nicely, Segment warehouse that stuff, and we could pull it out really easily just per user with security. So let me tell you about the lesson learned with commercial search. So this was the largest failure that I had with convincing any team to go serverless. And when this was acquired, the team that took it over had a DBA, had a bunch of back-end engineers, and the very first thing they decided to do with this was take out Firebase and replace it with SQL Server. But you can't do that. So you got to make a GraphQL middle tier. And then obviously that doesn't take care of authentication, so you got to re-implement auth in your middle tier. So anyway, a year later, they didn't have any new functionality, but got rid of Firebase, made it slower. But yes, I learned a lot about developer attitudes there. Fourth example here, Branch. This is a company I'm working on right now. It is an insurance company. And we, not a lot of details I can go through on the front end, but you're going to be able to buy insurance. And insurance is largely about you have a bunch of information, and that calculates a rate for you. It's very complicated billing, very complicated sort of data pulls. Very back-end type of a lot of back-end work needed. So let's start again, user browser, still React in this case. Serving, though, out of CloudFront off S3. And as an interesting note, CloudFront was created to be a content delivery network. We have all of the caching turned off on CloudFront. We are using CloudFront for not its original purpose at all. We use it purely as the front gateway to access a number of things. We have the same need for a blog. And so while the reverse proxy option here is not as easy as Netlify, it is as fast. And so Lambda at Edge allows you to basically make any reverse proxy you want in the Amazon ecosystem. We then, instead of using Firebase, we use a service called AppSync. If you're not aware of AppSync, you need to go immediately read about AppSync. It is a GraphQL API mainly set up by configuration that is run, that Amazon has created. And what it does is you configure all of the GraphQL resolvers by writing templates in Apache Velocity template library. And what it allows you to do is, with no code, only configuration, have completely secure ways of contacting a number of services. They're secure because you're using Cognito. So that is sort of the Firebase Auth 0 piece that Amazon has. By the way, if you used this a couple years ago, it was terrible. It is now quite excellent. AppSync will front Dynamo, fronts Elasticsearch, and will front arbitrary lambdas, which means that I can set up a completely secure way of querying Elasticsearch or writing or reading from Dynamo. In other words, from a user space standpoint, so I am a user, I authenticate with Cognito, I need to only be able to read and write my records. All that's completely handled here, just configuration, and most of the stuff, you're going to use like a pre-built template. They're very short. Also in this ecosystem, DynamoDB has this thing called streams. So every time you write something to Dynamo, you can stream it to somewhere else. You can stream it to a Lambda function, and you can then index it to Elasticsearch. So there's actually a very easy way for you to write to Dynamo, and then it shows up in Elasticsearch for searching with a 20-line Lambda that you can reuse across every table you had in Dynamo. You can also use those streams to write a bunch of data back to S3, which you can then query from S3. We use Segment here as well. And we query S3 using Athena. So all these are fully managed. To me, the main lesson I've had so far in building this is that you can go serverless even with pretty back-end rich applications you would think would require a lot of back-end work. Awesome. Let's get to patterns and anti-patterns, and then questions. So let me start with the first pattern-anti-pattern pair, which is you should have thick clients. You should not have thick middle tiers. This, as a corollary, says no VMs, no containers, nothing that's meant to be run by a middle tier. And this is one of those reasons why when people say, oh, I've got like this Ruby on Rails app or this Django app that I want to make serverless, I mean, my default view would be don't. That's going to be hard. The entire application paradigm, in my opinion, would have to change to be like get the value of a serverless architecture. It's OK. Leave it where it is. But for pure greenfield, you can just dispense with all that middle tier code in most cases. Second pairing. How do you think about functions? So the pattern is that functions are glue. So if you look at the branch architecture, functions exist to connect things together, and then Amazon in the Lambda case, or Google in Google case, watches what you're writing functions for, and then eventually says, let's just build this into a service. So like literally just launched was SQS to Lambda. SQS can now trigger Lambdas, needed for years. But that's what happens, and then you replace the glue function. The functions calling functions is a nightmare. You will imagine an infinite loop of functions calling functions, but you have to pay for every function execution. It's a big problem. And it's one of the reasons why people like Ben Kehoe of iRobot, who does a lot of work here, will tell you, don't have functions calling functions, deploy monolithically. So I'll get to that in a second. My view is one function calling a function is OK. But the idea that you're going to take the architecture that you would have had in an application with a thick middle tier, decompose it into functions, and set those up as different functions, which, by the way, is like a lot of how pundits talk about serverless architectures. I actually think it's one of the things I don't like about SAM is that it kind of implies that you should be doing this. I don't think this is good. I think this is a really strong anti-pattern, and I think if you talk to people who've been doing this for a while, they will tell you, don't have functions call functions unless you're like really sure it's the right way. So I'd much prefer, for example, to have shared modules, do a monorepo, use Lerna, have shared code, and then just deploy each function monolithically, and don't have them call each other. Next pattern, anti-pattern, and this one has some nuance. But you should use lots of services. And so I've shown you a lot of the first three architectures were like this just collection of different services, whereas the fourth one in branch was still a lot of services, but all in AWS. And that's great, and you should do that because, as I said before, it's like you have your own development team working there. What you don't want, though, are multiple single points of failure. And so one lesson we learned, this was shocking to me, was that Cloudflare was like horribly unreliable compared with our other services. And we had to drop Cloudflare, which is crazy because of some insane volume of traffic goes through it, right? About a year later, they published the bug that we were running into. So maybe it was just affecting like some applications. But you have to be very cognizant of whether the service you are trying to use has the right uptime. So one of the things that we did was we set up up-down monitors with specific dynamic calls to those, and we would run them like every 5 minutes for a month or two just to make sure that they look good. And then we would just monitor them. But all the services that I've listed have had great uptime, and they've been around for years. But you do need to pay attention to that. One other brief comment on this slide is that the lock-in question is going to keep coming up. Right? But the reality is, go pick a service, get live, and if you don't like being locked into it, then re-implement it because you're going to have to implement it anyway. Right? So just skip the first implementation phase, use the third-party service, and if you don't like it, write it yourself. Second to last pattern, anti-pattern, you should be spending a lot more time doing research and code. This is a very hard thing for organizations to do because if I say we need to develop X, and I have a developer say, okay, well, I know how to do that with the methods that I've been using for several years. There might be a better way to do it. Maybe there's a service that does it for us, but I don't actually know about it. So I can tell you today, I can get this done in 2 weeks if I develop it. Maybe I can do it for less time. Maybe I can do it the same amount of time, a lot less code, but I don't know. So you have to have discipline around, it's okay to take some time to do some research. And I always tell my developers, I'd much prefer, if you said, this is going to take me 2 days of sort of planning and 2 weeks of development, I'd much prefer you take 2 weeks of planning and 2 days of development if you think that's even a possibility. Finally, and maybe the most controversial pattern, is I believe that you should do monolithic deploys to start. And this is really my how I maybe pay homage to Martin Fowler and his start with a monolith. Because when you live in this environment, you get a lot of these great microservices. I mean, again, you're getting this sort of beautiful microservice architecture for free, opinionated, it's great. The problem is it can be a complete nightmare to figure out like what version of something you are running to track down bugs and to do testing. If you make a monorepo and you deploy monolithically, at least to start, first of all, your continuous integration, continuous deployment is great because you can actually deploy the whole thing. Remember, prod environments for everyone. You run full end-to-end test suites on a completely separate environment that is instantiated from scratch. You know that it works, and you know you found the bugs. So excellent. Well, so I'm hoping now that you've heard my patterns and anti-patterns, I hope you feel excited. I hope you feel a little challenged. And you'll start experimenting and at least talk to me on Twitter about your experiences and what you've seen, and that is my Twitter handle. So thank you. And I'm happy to take any questions you have, as challenging as you'd like to be.
Hi. So I've heard, particularly with Java, don't do monolithic deployments. The startup time of the JVM, do much smaller deployments, then it only impacts one Lambda function rather than all of them. Any comments?
I suppose I mean, if you're building functions to run ephemerally, and you have the possibility for warm starts by pinging, the container, I'd solve the cold start problem, but I wouldn't make, in my view, I wouldn't make an architectural decision designed around speed that there's a workaround for, because I think the complexity of the deployment has like way worse consequences than maybe having to ping these things constantly to have them be warm. And are the questions getting recorded enough, or should I repeat them? We're good? OK, awesome. You can cut that out of the final edit there.
Have you run into problems with the limits imposed by Lambda? So there's like the limit that you can only run 1,000 concurrent functions. There's limits on memory and time.
So you can get the concurrency. There are a variety of ways to handle the 1,000 concurrent issue. And so I haven't had a problem with that one. With the other ones, I mean, I'll echo what Tyler at Bustle said, which is that if you have long-running functions, like this isn't the place to run them. But I have not. We have been able to design our processes so that that's not an issue, or where our long-running functions can run through something like Amazon Glue, which is a platform for doing data processing that it runs the Apache Glue project. But I can imagine situations like Tyler talked about, which is where I've got excessively long-running code and I kind of want to run them somewhere. The only thing I would say is you shouldn't need that code for uptime. So like, I'm certainly not opposed to saying like, oh, I've got some containers that are running. They're not responsible for uptime, so I don't need server ops for uptime. But I do use them for like back-end processes, and if they die, I can just spin them back up. And in terms of memory limits, not run into any problem, but I mainly live in JavaScript and Python, so it's possible I would run into those with other languages. I don't know. But I haven't. It's not been an issue.
Hi. So with all of these different kind of services and Lambdas, whatever running, I mean, do you have any challenges, or how do you address kind of having observability into your system and really kind of debugging and understanding it?
I mean, in my experience with all of these systems, so let me echo use of Sentry through Segment. I mean, one of the challenges that I've had is that people tend to want to think about observability from a back-end standpoint, right? Which is like, I want to understand what's going on here. In my experience, most of the bugs are in the front-end code, especially as 90% of the development goes to the front end. So I find services like Sentry to be like where most of the bugs come from and where most of what I need to understand is. I believe when you do these architectures correctly, it's not only your uptime that you're outsourcing to your cloud provider, but you're also outsourcing a lot of these standard things that require observability. I do think, again, talking to Tyler's talk earlier, I do think if you're using API gateway and Lambdas and you're handling a lot of HTTP requests that way, like I think you're going to need the observability aspects that he's talking about. But we don't do that, right? So if you think about CloudFront and AppSync, like they're handling those types of things. And so in my experience at least, and I mean, I'm not dealing with 80 million monthly uniques, right? So it's possible at 80 million monthly uniques this changes for me. But I can tell you at over 500,000 monthly, over 500,000 monthly uniques and like load balancing way above that, it's not anything that we ran into. And I believe largely because we outsourced that problem to our providers.
Hi, nice talk. Question about, so we are currently running Express in Docker containers, and we have different routes, and we're trying to scale this out to different teams. And it's come up, and I can follow up afterwards if this is like really specific, but it's come up on our radar the past couple months that maybe we could just be doing this in Lambdas or functions. Can you comment at all on that? Like what the trade-offs would be? Do you need to know more?
I think, so my general view is that migration is not a great one. And it's because if you live in Express and your developers live in Express, they're thinking about the thick middle tier. I mean, you've just got this application and it's doing all the mediating and the moderating. I mean, what I'm really saying is that if it were possible for you to look at like a Firebase or an AppSync and say like, and you looked at your code base and you said, wow, I'm comfortable and okay with this maybe taking, like a couple months, maybe longer, but potentially also we're just going to throw away like 80% of the code in here and we're going to go like re-implement it in configuration for these services, then I think you're in a good place. But I mean, my own view would be the time it would take you to migrate that middle tier to individual Lambdas would not be worth it. If I were there, my feeling would be, no, don't do that. Instead, go make the DevOps as good as they can, handle the failover scenarios as best you can, and put your money and time into the front end, which is what your customers are going to care about. I mean, that would be my view on that existing application.
Okay, I think we're out of time. Let's just thank Joe again for giving us a great talk.
Thank you.